Welcome back to another video, and this is the second video in the complete recursion series. So in the first video we did the introduction of recursion. That video is very important to watch. Please watch that video first. By the way, we're doing the entire data structure algorithm bootcamp, and recursion is also a part of it, and we've already done introduction to recursion video is already done. So in that video we actually shared how to learn recursion, how to understand the problems, and now let's say we have given an introduction to recursion. Now to the most important part, which is lots of concepts and questions. So this is going to be a series, so I'm going to be making video on right now we're doing this video is about basic easy questions on recursion. This is just to give an idea about like some little bit basic practice to students. After that I'll teach you recursion with arrays, so like how to return arrays, how to pass arrays in the argument in recursion and stuff. After that we'll learn about recursion with patterns, so patterns forming with recursion, sorting and searching with recursions, we'll do that. Then we'll do another video on recursion of strings, we'll do that. And after that we'll do one more very important video, which is recursion questions on subset questions. And after that we'll also do questions on backtracking, which is also a part of recursion. There will be doing n queens and n knights and sudoku solver. Basically questions like this we'll be doing in this complete recursion series. So make sure you like, share and subscribe. Let's get started. So this video is about basic recursion problems. I am not going to repeat the things that I have already shared in the previous videos, because that is a waste of time. It does not make sense to say the same thing in every single video. That is why I reference it. I'm like, okay, I've explained this in detail in this video. Please watch it. Link in the description. Timestamps are also added. So how to understand recursive problems, what is the recursion tree. So in this particular video, you may have doubt, like if you have not seen the previous video, then you will have doubts like what is recursion tree, what is call stack, how the arguments are passed, how the function value is returned, from where the value is returned. All these doubts will be solved if you just watch that video once. The introduction to recursion video. Okay, this is specifically about questions. Let's get started. So in the first video we saw like how do we actually approach a problem, right? So what do? We build a recursion tree. So when we are given a problem, we try to see how to break that problem down into smaller problems. That is what we do. So for example, if I want to print, let's say something is given to you like n is equal to 5. N is equal to 5 is given to you. So you're like n is equal to 5 is given to me. Question says print all the numbers from n till 1, for example. Okay, so you have to print 5, 4, 3, 2, 1. That is what you need to do just by calling a function. You can only call one function like that. So you can be like, okay, I'm going to call function with the argument 5. This is going to print 5, and then it's going to say, hey, function 4, print all the numbers from 4 till 1. It's going to be like, okay, this is going to print 5, and it's going to now be in the stack. Let me draw the stack as well. Again, in detail explanation of this already given. When a function call is called, while it is waiting for the other call to finish, it's going to rest in the stack. I explained this in detail in the 2-hour long video. The 2-hour long video is nothing but an introduction to recursion. Please watch that video. Your doubt will be cleared. Very important video that will make you understand how call stacks and everything is working. I'm not skipping anything. Please watch that video. All right. Then it's going to be like f of 4 is going to be like the function will be called with argument 4. Same function. It's going to be like, okay, I'll print 4. It will print 4. And then it's going to be like, hey, let me ask the function call 3 to print 3, 2, 1. It's going to be like, hey, function call 3. Like same function call with argument 3. Can you please print 3, 2, 1? And by that time, I'm going to be resting in the stack. And f of 5 is, or function of 5 is also resting in the stack. F of 3 is going to be like, yeah, sure, I can print 3. Similarly, I can call f of 2. F of 2 will be like, yeah, I can print 2. I will call f of 1. F of 1 will be like, I can call 1. Do you want to print 0 or something else? They're going to be like, no, we don't. We don't need to call anyone else. Example, f of 3 is here. This is stack memory explained in detail. Then f of 1 will be here somewhere. F of 1 I'm going to be like, okay, I'm not calling anyone. I'll be removed from the stack. Remove, then remove, then remove. How this removal happens already covered in introduction to recursion video, so make sure you check it out. Okay, and by the way, I've also shown this by debugging. This entire question we have solved in detail via running the program in debugger. Okay, so we can do this. This is very simple. So now if we write the pseudocode for this, so we can just be like, okay, there's a function that is known as, let's say, fun. It takes a number. What does it do? It prints n. That's it. And it calls function of n minus 1. That is it. And a base condition will become over here that if n is equal to 1, just print 1 and return. That's it. Nothing else we need to do. Just return from it. And I also explained this in detail, how to form this particular pseudocode. You have to think about what is the return type. And I also told you if the return type is void, you don't have to write return function call. Because if the function's return type is int, whenever you're calling that function call, you have to return this. That is something we'll look into later on. Okay. But right now, what is the return type? Nothing. You just need to print. You just need to print 54321. Hence, no return type. Hence, no need to say return f of n minus 1. No need to do it because there is no return type. Just call it void. Okay. This is something I explained in detail, but I will also explain this as an example of with a return type. That will make things more clear. Let's try to code this thing. So I've created another package called easy. I can say something like, n to 1. N to 1. Okay. So is there a return type? No, there isn't. So void, I can say fun. It's just taking an integer n. And then what is it doing? It's saying that if n is equal to 1, or I can say if n is equal to 0, just return. Don't do anything. That is also fine. Recursion questions can be solved in many ways, right? So you can do it in many ways. And then I can say otherwise just print n and call function of n minus 1. Already explained in detail in previous lectures. That is it. If I just say print, not print, I'm not returning anything, so I can just directly call this 5. Okay. Run. I also showed you how to debug this. It will not make sense if I debug the same program again and again. You can do it on yourself. 5, 4, 3, 2, 1. Very simple. I can do it as a reminder again, but I should not be doing this because I've already done this many times in the previous lecture. Click on debug. You will be able to see how the stack memory is getting filled and everything you will be able to see. Here you can see the stack memory. Main is in stack. Then the function call for 5 is in stack. Then it's going to check. Hey, is 5 equal to 0? No, it's not. Okay, move ahead. Print 5 and now call for 4. Now 4 will be over here. Now this is for 4. Function call 4. This fun is again over here, right? Print 4. Again fun will go on the stack. Fun is again on the stack, and while these two are waiting, as you can see, this is waiting, this is waiting. Now this is in the stack. It will print 3. 3 will be waiting. It will be waiting for 2 to finish. 2 will print itself. Now it will be waiting for 1. 1 will finish itself. It will call 0, and 0 will not do anything. It will just return. That's it. Now how will it get out? How will it get out? We already saw it. Whenever you call a function, when that function finishes executing, it gets out from where it was called. Okay, it will not make sense to you until unless you try it on pen and paper. Okay, I explained this same question in detail previously. Please make sure you check it out. Okay, that's it. All the function calls will be removed from the stack. Now you may ask, Kunal, what if I want to print 1, 2, 3, 4, 5 instead of 5, 4, 3, 2, 1? Pause this video and think about it. Okay, so now if you have paused this video, so you're saying that when you are emptying the stack, then only print. Because now you don't want to print 5, 4, 3, 2, 1. Remember what is happening. You pass 5, you print 5, and then you call the recursion call. For that recursion call, you print 4, then you call the recursion call. That is not what we want to do. We're like, okay, you're passing 5. This 5 I will print at the end. First, give me the answer for 1, 2, 3, 4. Let me bring up my this thing, drawing pad. So okay, so what if you want to print 1, 2, 3, 4, 5? N is given 5. Answer should be 1, 2, 3, 4, 5. So instead of printing 5 when you call function of 5, instead of printing 5, because if you print 5 right now over here, it will print 5, 4, 3, 2, 1. Okay, so basically the idea is that you're like, okay, I will print 5 later on at the end. first print 1 2 3 4 for me. It's going to be like 4. 4 is going to be like, okay, I'll print 4 after 1 2 3. So it's going to call 3. Till this time these will be in the stack. F of 3 will be like, okay, I will print 3 later on. Let me first ask the other function calls to print 1 and 2. After they have printed 1 and 2, then only I will print 3. Okay. 2 is going to be like, let's print 1 first. Okay. So 1 is going to be like, that's it. I can print myself. So 1 can print itself. Then it will be out of stack, and from where it will be removed? It will be removed from where it was called, and it was called here. You do realize this chain, right? If this is chaining to this, means that this function was called when in this function's body. It's very simple stuff. I covered this in detail in the previous section. Okay, so it will be like, okay, this is removed from stack. Now we are in this function call. This has just finished. Now I can print. So basically, when the function call has finished executing, then print your number. It will be also finished executing now. So when this function call is finished executing in this function, then print 3, then print 4, then print 5. So which function, the function for which you are waiting for, that you have to first wait for it to finish and then print. So for example, if I just copy this, I can say reverse. I can say fun reverse. So basically the idea is, once it has finished executing, it will come out from here, then print. That's it. Let's call fun reverse. One, two, three, four, five. How easy is it? Very easy stuff. These are easy questions, but very important to grasp. It's not just it should not just be like, okay, I'm able to solve it. No, understand in depth how these things are working, how every function call is working. This will help you in solving complex problems. That is why I'm teaching you first easy questions. Okay, because then you will say, Kunal, you directly jump onto difficult questions and you're not like true to your words. It's not beginner friendly course. No, good cool questions will also come. All right, let's move forward. Now what if you want to print 1 2 3 4 5, like 5 4 3 2 1 and 1 2 3 4 5? Very simple. Just print this also and this also. It will print, like if you put S out over here, then while it is forming the recursion calls, it will keep printing 5 4 3 2 1, and once the calls are removed out of the stack one by one, then it will print 1 2 3 4 5. Both the concept we just learned merge into one. You can say fun both. Please, I have explained in detail how to understand these questions in the previous video. Hence, please check that out. Okay, so I can say fun both. This will print 5 4 3 2 1, then 1 2 3 4 5. So 5 4 3 2 1 and 1 2 3 4 5. That's it. As simple as that. Complexity you can figure out yourself because it's just printing n times. So O of n. Space complexity will also be O of n because it's storing that many function calls in the space. We already talked about the space complexity of recursion in the space and time complexity lecture. That is also something covered in detail. Link in the description below, the playlist. Entire playlist is available over there. The ongoing, or if you're watching in the future, then the complete Java plus data structures algorithms plus interview preparation playlist. Cool. Let's move forward to the next question. Okay, it may sound a little annoying, like Kunal, you are repeating these things, the same guidance thing you are in your recursion video repeating again and again, but it's very important. Anyone can solve questions. Any YouTube video can give you the solution to all these questions. But nothing is going to benefit you if you're not doing it if you're not following the steps that I mentioned in the previous video. If you're not writing it on pen and paper, if you're not building the thought process like I am over here right now. I literally mentioned to you like the steps, so basically that's the idea. Like the steps are very important. Okay, so please make sure you do that. Just follow the steps, like how to understand recursive problems, like building the tree, seeing where the call is happening, how the function is getting executed and finished, and how the stack is forming, how the stack is getting emptied. mentioned in the previous video. Now let's look at another simple question, but very important for some concepts that I was telling you about before. Now this question states that you have to just do a factorial, but okay, factorial is an easy question, but very important concepts over here that will help you in the future. So please pay attention if you are new to recursion. So factorial of a number. Factorial of a number. We have already done Fibonacci of a number, so please watch the previous video for that. Let's say factorial of a number. What is factorial of a number? Let's say you're given, let's say n is equal to 5 or something. Okay, the answer should be equal to what? Answer should be equal to 5 factorial, which is going to be equal to 5 into 4 into 3 into 2 into 1. Okay, something like that. So basically this is equal to what? 120. Okay, that is what we want to do. Again, recursive problem, try to see what are the recursive steps that you can break this down into. That's in the previous video I mentioned, like how do you approach a recursion problem, because anyone can teach you. There are lakhs and hundreds of videos on factorial of a number on YouTube, but try to see why are people doing it the way they are doing it. What is the approach? What do we need to think about? Function calls, return value, how arguments will be passed, what will be returned, how the function will come out of the loop, and all these things. So basically here what you want to do is, first we see what are the function calls being repeated. Can you see that if I'm saying factorial of 5, can I not write this as 5 into factorial of 4? Because this is equal to what? 5 into 4 factorial. Can I not write factorial of 4 as 4 into factorial of 3? Now can you see the recursion pattern? That's it. So what is factorial of n? The recursive call that we made previously. What is factorial of n? N multiplied by factorial of n minus 1. That's it. That is it. What is the base case? Base case can be something like factorial of 1 is equal to 1. That can be our base case. That's it. Now that you know how it's, the function call, now let's see how it's working internally, like the graph of it, the tree. So basically tree is going to be look something like this. F of 5, this is going to say, okay, the answer is actually equal to 5 multiplied by whatever the answer is of 4. Is going to be like 5 is going to be like, okay, I will get multiplied by whatever the answer is of this thing. But first give me the answer of this thing. Okay, f of 5 is going to be like, hey, f of 4, I will give you 5 to multiply in yourself. But at least give me the answer of it. F of 4 is going to be like, okay, give me a second. Till then, we both can rest in the stack memory. I will ask f of 3. I'll going to be like f of 4 multiplied by f of 3. It's going to be like, hey, f of 3, I am ready to give you I'm ready to give you 4. Can you please give me the answer of 3 factorial? What is f of n is n factorial basically. This means n factorial. It's going to be like, okay, this is equal to 3 into f of 2 means 2 factorial. This is equal to 2 into f of 1. F of 1 is going to be like, okay, I am the base condition. My answer is 1 only. F of 1 itself is 1. It's going to be like, okay, then multiply it by 2. Then it will come out of the stack. It will return its value. Here, return its value. Here, is it printing value or whatever? What is it doing? It's actually returning the value. So what is the return type of the function going to be if it's returning a value? Let's say integer value, int. And what trick that I told you before? If the function type is int or anything else, the recursion calls also have to return. Obviously, because this function is, I am not sure how to explain this in a simpler way. But I'm not sure if you're able to understand the common sense behind this. Please put a little efforts in this. Like, it's very simple. It's common sense. See, the thing is, if integer value is asked to be returned in a function call, then a call of that function is going to return integer only, right? If f of 5 is asked to be returned at integer, then f of 4, that is also the function call of the same body. So it's also going to ask to return an integer. So wherever this function call is called, this function call is called, this is called, this is called. Wherever this is called, it will return an integer. This entire thing will be an integer. Hence I have to return this. This was the intuition behind it. Why we are returning every function call when there is a return type? Because the function is body is same. You're just calling that function only. And that function requires you to return something. If you don't return it, then what will you return? Void. You can't return void. Int is required. Okay. So when this comes out of the loop, when this function is finished executing, it will come out of the loop and it will actually return the answer of f of 1. Answer f of 1 will be returned and it will be stored where? Very simple. This is the first lecture of functions. Where is the function return value stored? From where it was called. Very simple, very basic first lecture. Okay, so this will return 1. So this entire call will be equal to 1. 2 into 1 will be equal to 1. Now this entire, so 2 into 1 will be equal to 2. So this entire thing now will be equal to 2. This actually will return 2. It will literally return 2, not print or anything. This entire value will be 2. It will be stored somewhere, let's say. And that here it will be like, okay, now this is 2. 3 into 2 is 6. Now this value will be 6. When this comes out of the function stack, this will be 6 into 4. 24. And now it's going to be like 24 into 5. 120. Make sense? Very cool stuff. So this will be 24. Okay. So 4 into what was the answer for this? 6. Right? So 4 into 6 is 24. And this will be now 24. So 24 into 5 is 20. So this entire thing will be 20. This will now be returned from where? This will now be returned to main because it was called where? It was called in main. And that's your answer. That's it. As simple as that. How easy was this? The function call and everything. Okay, let's try to code this. I'm going to say factorial. You can try for long or whatever. But I'm going to just, for the sake of simplicity, static int factorial, it just takes an integer n. That's it. It's saying if n is equal to 1, what do I need to do? Just return 1 only, because factorial of 1 is what? 1. In case you try for 0, so 0 factorial is also 1. In that case also I can say, let's say, if n is less than equal to 1, in that case just return 1. If you put 0, it will return 1. If you put 1, it will return 1. Okay. And then I can say, we are imagining that we are not adding negative numbers. And after that, what can I do? Just return what? N into factorial of n minus 1. That is it. That's it. Answer. Why am I returning this? See, I am returning this. I am returning the function call. Okay, previously in printing, what I was doing something like this. But I'm actually returning the value because I already explained this. So answer will be returned. So this value will be returned. The entire answer will be returned over here. And I can just say print answer. Should give me 120. 120. Okay. You can debug it as well. One by one. That's it. As simple as that. Similarly, what can you do? Sum. Similarly, you can do sum. What do you need to do? Sum of n numbers. Okay. That is what you need to do. So what is the sum of n numbers going to be? Instead of multiplication, let me just change the name so it's not confusing. Instead of multiplication, what are you doing? Addition. Is there any change in this? In factorial, you are doing multiplication. Here you're doing sum of n numbers. What's so difficult in this? What is sum of 5, 4, 3, 2, 1? Let's see. 15. Now let's do another question. This is called sum of digits. Now notice something, we're not saying sum of like the range or anything. No, but actually sum of the entire digit. So basically question says sum of digits. So basically let's say n is given to you like 1342. The answer should be equal to 1 plus 3 plus 4 plus 2, which is equal to 4, 4, 8, 10. Answer should be 10. So actually sum of individual digits. If you want to do it normally, how can you do it? if you want to do it like normally. Basically here also we can see how to break it down into smaller problems, right? So this can be basically broken down to 1 plus sum of digits of the number 342. Okay, this can further be broken down 3 plus sum of digits of the number 42. As simple as that. Make sense? And that is what we're going to be doing today. So how can we do this? How can we do this thing? So basically the idea is that what is the base condition going to be? Obviously, well, if the number is 0, return. If the number is 0, then return the number itself. Return 0. Okay, that's it. Maybe that can be our base condition in order to make things simpler. So basically the idea is that f of n, okay, it's equal to like the first digit, whatever digit we have, let's say, yeah, whatever digit we have. Or how do we actually get the individual digits? We can take remainders. Make sense? You can take remainder by 10. We have done this previously as well. So if you want to get 2, then 4, then 3, then 1, how do you do it? You just say remainder is equal to n modulo 10. So remainder is equal to n modulo 10. So you know 1342 divided by 10, remainder will be 2, and that is it. 2 is you are getting. Then n will be reduced to n divided by 10. N will now be reduced to 134, something like that. Okay, so I can say that f of n means the sum of digits of all the numbers in all the digits in n is going to be equal to what? All the digits in n divided by 10, right? Plus the digit last, which is n remainder 10. That's it. That is it. You know, you want to build a tree for this, you can do it. So basically the idea is going to be that 1342. So it's going to be like, okay, what are the sum of 1342? It's going to be like the remainder 2 plus whatever the sum is of 134. It's going to be like 2 is going to be like, okay, yeah, I'll wait. Give me the answer of 1 plus 3 plus 4. 2 is going to be like, I will wait. Obviously, what are we returning? Number. So return type will be what? Integer. Hence, we would have to return this thing. We cannot leave it without return because of the same concept I explained to you previously. I explained it to you very in detail for 5 minutes, I think. So it will be very not good if I explain it again and again. Okay, because this is actually asking, 2 is actually waiting for this to return 1 plus 3 plus 4. Hence it has to return, literally say return 1 plus 3, 2 plus 4. Okay, 2 is asking for it to do it. That is why I'm going to say return whatever answer you're getting. When it calls this, it's going to be like return 4 plus whatever the sum is of the digits 13. So whatever the answer of this is, it will actually return from where it was called. It was called from here. Okay, very simple. Let's code this. I think after doing factorial, this should not be an issue. So actually a very simple problem now. So I'm gonna say digit sum and complexity. What is complexity? The number of digits. You've seen what are the number of digits are obviously in maths for in the number theory video that we did. I explained to you how to use log to find the number of digits. Complexity is log n. Okay. Cool. So we are just going to say static. What are we returning? Integer. Okay. I'm going to say sum of digits. Integer n will be available over here. All right. And I explained to you previously as well in the intro to recursion video, and this will be much more clear when we do arrays and more complex question. Whatever thing you pass over here in the argument, that will be passed to the recursion call. Whatever you add over here, whatever variables you create over here, they will only stay for that recursion call. If you are not understanding what I'm saying, it means you have not watched the previous video carefully. I explained that specifically. I even wrote that in my notes, and many people who watched the video, they also gave a shout out, like what a brilliant way to share. Okay, please watch that video. I explained it very in detail. And what do we have on the whiteboard over here? It's just basically going to be like, if n is equal to 0, that's it. Otherwise I can say that just return what? N modulo 10 plus sum of n divided by 10. Okay, let's try to run this. I'm going to say sum of 1342. What is the answer? 1342. 10. 10. Simple stuff. Similarly, if you want to do product, digit product of all the digits in the, what do you have to do? I just rename this, so no actual change in the concept right now. Product, instead of addition you can do production. But here just a very slight change will be required, because when it returns 0 and all the answer that you have gotten, anything multiplied by 0 gives 0. So in the end it will give the answer 0 only. So it's a, maybe what we can do is, if one digit is remaining, return that digit. Okay, maybe we can do something like that. So you can say if one digit is remaining, if n modulo 10 is equal to n itself, then return n. What is 1 into 3 into 4 into 2? It's actually equal to 24. That's correct. Let's say 55. This should give me 5 into 5, 25. But it also works if there's a 0 in it. So as you can see, the digit 0 is in this, so answer should be 0. 0. Okay. Similar concept. Let's move forward. Let me teach you another concept about like passing numbers, right? So it's an important concept. So I'm just going to teach you over here. I'm going to say concept. I'll write some code and you tell me what the answer will be. Okay, I'm going to say void just a function. Okay, and I'm going to say if n is equal to 0, just going to say return. Okay, and then I'm going to say print n, and then I'm going to call this function. I'm going to pass n minus minus over here. Okay, I'm just going to say n minus minus. Now if I call this with 5, okay, so it's like, okay, print 5, then n minus minus, 4 n minus minus, 3 n minus minus. What should be the output? Tell me. Pause this video, think about it. Okay, I hope you thought about it. Let's try to run this. No, don't just think, write it on pen and paper. Okay, let's just run it. Infinite recursion. Infinite recursion. Stack Overflow. We talked about it's just printing 5 only. What is happening? You're like, Kunal, why is it not subtracting? Well, n minus minus means n is equal to n minus 1. That's correct. But no. This is the concept that we learned about. It's like n minus minus versus minus minus n. It's not similar. N minus minus means, let me just bring my whiteboard. Okay, so let me just write it down. I'll write down in red color. N minus minus versus minus minus n. What is the difference? Both are like n is equal to n minus 1, right? So then what is the difference? Difference is this. This will pass the value of n first and then subtract it. So if I'm saying n minus minus for n is equal to 5, it will pass the value of 5 first and then subtract it afterwards, when after the function is over or whatever. But since it's already subtracting, adding, it's already passing 5, then you want to pass 5 minus 1, then it will again pass 5, then you want to pass 5 minus 1, it will again pass 5. It's always passing 5 only. It's not actually subtracting. That comes later on. Okay, and here it's like actually pass the value of n first. Subtract first and then pass the value of n. Subtract first, then pass. Okay, there was a basic concept I want you to know. So let's try to change our code. I can instead say minus minus n that's it. Cool. I can actually put it over here. concept. I'm gonna say concept only. Okay, sounds good. All right. Let's move forward to the next question. Okay, now let's look into the reverse a number problem. Let's say another question we can take is reverse a number. This is something we have done via, and by the way, try to solve these simpler questions like iteratively, and then you can also try like recursively. Usually it's the other way around. You first solve complex problems using recursion. I covered this already. I'm not sure why I'm saying it again and again. So recursion makes it simple for us to solve bigger problems into smaller problems. Then you can use iteration to convert it into iteration. So reverse a number. Reverse a number using recursion. N is given to you 1, 2, 3, 4, 5. You should return 5, 4, 3, 2, 1. Okay, it does not have to be sorted, so you can take it like 1, 8, 2. You should 4. You should return 4, 2, 8, 1. How do we do this? What can be the recursion call in this? Recursion call in this can be that, hey, this, if I want to reverse, I can say that I will add, if you just reverse, let's say this half of the array, and I'll just add 1 over here. Let's say some 1 over here. First one will come at the end once you just reverse this. Now this is the sub problem. You can use apply recursion over here also. This can be converted to, hey, try to reverse 24, and I will add, let's say, 8 over here in the end, in the output. We cannot convert it into strings. Okay, so we have to do it without strings, so we have to think about it. Or we can do it like the other way around. I can say I can get the last elements, or I can say that I can get, hey, what you can do is, let's say instead of this, you can say, okay, if you want to reverse this entire thing, right? You want to reverse this entire thing. Try to reverse 182, like the first one. Try to reverse 182 and add 4 in the beginning. Add the last digit in the beginning plus try to reverse 182. Something like that you can do. Now this can be like, add the last digit in the beginning, try to reverse 18. Yeah, now it makes sense. You may be asking, Kunal, how were you able to come up with this? Because we have already done this thing. Okay, you just take one element, put it in the first, last, take the last element, put it in the first, take the last element, put it in the first. Okay, so basically whenever this is a pattern, okay, that is why I'm able to solve it very easily. Whenever you ask like digit by digit problems, in that case you are going to be taking remainder and dividing the number by 10. Okay, that is the pattern. And this can be 8 plus reverse of 1. So basically it means that whenever you're trying to reverse a digit of 1, like a single digit number, just return that number itself. That is what we can do. Okay, so it can be like function n is actually equal to, last digit will go over here. You will add this with what? You have to add it, right? You have to add it with the reverse of the remaining, which is n divided by 10. 182 is what? N divided by 10. So reverse of n divided by 10, this will give you the reverse number. But how do we actually add it? I need to get the 4 to the thousands place. Okay, how do we do that? Many ways to do it. I'm just thinking which one to tell you or I can tell you all the ways. You can either take a separate argument. So there are a bunch of ways via which you can do this. So one of the things that I'm trying to figure out is like, how do we actually increase this particular like 4 to, towards the thousands place? So what you can do is, the number one way you can do it is, let's say, take the value of this base counter in the argument itself. That is something you can do. We can try that. Or what you can do is you can take a separate answer outside the function and you keep updating that answer. You can do that, right? That's the easiest way. One more thing you can do is you can take a separate like base outside and you can then keep updating like usually in the file. Let's talk about it. Way number one. So way number one basically means what? Okay, so way number one basically means that you will have your function over here. Okay, your function will be over here and your function is going to contain the number n. Okay, so basically what you're going to do is you're going to say that if the number is not equal to 0, okay, in that case you're just going to say, or here I'm just going to take a sum outside this. Okay, you're just going to say remainder is equal to, I can just say if sum is equal to 0, return 0. Base condition can be over here. If sum is equal to 0, or you can just say return, no need to return 0. Okay, and then you can say that something like this. You can say we know remainder is equal to n modulo 10. So if I'm saying the number is 1342, okay, the answer will be 2431. How? Because I know remainder is equal to n upon 10, which is 2, and it's going to be like 2. Reverse it, just put it at the first and reverse whatever that you're getting over here, means reverse 134. Okay, what is the actual answer initially going to be? It's going to actually start adding from 2, then 4, then 3. So 2 will be added first, okay, then 4 will be added, then 3 will be added, then 1 will be added. That is what it's doing. So one by one it's adding. So as you can see, first 2 is added, then when 3 is added, 2 comes at the tens place. So instead of, how do we do this? How can we say that 2 plus 3 will give me something like 23? Can I not do something like, if let's say initially the sum is 2 over here, okay, can I not say 2 into 10 plus 3 is equal to 23? Now when I want to add 4, so okay, when I want to add, sorry, it will be 4 over here, not 3, 4, because 4 is the second one. So it will be like 24. Okay, 24 will be available over here. And after that it's going to say, okay, now the n divided by 10 is giving me 3, like the remainder is now giving me 3. How do you add 3 over here? It's going to be like, okay, multiply this by 10 plus 3. By the way, we have covered this previously. It's going to be like 243. Now 1 will be available here into 10 plus 1, which is equal to 2431. Only recursion that is happening is n divided by 10. That is the only recursion happening. Main value that is getting updated is outside. Hence, no return value is required. Why do we need to return value? We need to return value when some answer is being calculated for some number inside the function. Why do we need to return value? Because the value that is formed inside the function, the variable will have the scope inside the function only. In order to access it outside the function, we have to return that value. But since the number is already outside the function, over here you can just do calculations. Okay, so you can say sum is equal to what? Previous sum multiplied by 10 plus remainder. That way, one by one, it's getting multiplied by 10 and 4 is moving towards the thousands place in 4, 3, 2, 1 or whatever you want to do. Okay, and in the end, I'm just going to say, okay, once you have moved 2 and 4, now trying to move n divided by 10, then again move n divided by 10. I can just call function of n divided by 10. Sort of like cheating because I'm using an extra variable over here outside the function. Okay, I'm using an extra thing outside the function. That is why this is cheating. It's not like pure thing like I want to do it just using recursion. Okay, in that way we can also do something. Okay, maybe you can take a base over here or something. Okay, let's see how we can do that. But I think this is very clear. One of the ways you can do this. Second way I'll teach you. I can code this as well, by the way, if you want. Let's code this. Okay, and then you'll say, Kunal, you skipped it. Okay, so here I can say reverse a number. Many ways I can teach you. So one way can be something like I can take a number outside, static int, I can take sum, okay, which is initially equal to 0. And then I can say, what is the static? We'll cover in object-oriented programming. So I'm not returning anything because I'm already changing the original value that is outside it. So here I'm just going to say this sum is going to be like, this is something we'll cover in scoping. Okay, don't worry, like the outside. Kunal, how are you forming this variable outside? Okay, so we'll cover it when we do the scoping things. In like, I believe I covered this like a little bit previously, but we can dive more into it when we do object-oriented programming. Okay, so let's take an outer variable that can be accessed via all the functions and everything. And I'm just going to say reverse method number 1. It's just taking a number n and it's saying if n, my alarm went off for something. If n is equal to 0. Oh yeah, by the way, over here I did sum. It's not going to be sum, it's going to be n. N is equal to 0, obviously. Okay, so if n is 0, don't need to do anything. Don't do anything. Then I can just say remainder is going to be n modulo 10, and I'm going to say sum is going to change the original sum is equal to sum multiplied by 10 plus remainder, and then I'm just going to say call and divide by 10. Okay, actually going to put it above it somewhere over here, let's say. Then we have just following conventions. So I'm going to say, I'm just going to call reverse 1 1 2 3 4. Then I'm going to print sum. Sum should be reversed to 4 3 2 1. 4 3 2 1. Okay, and now you may ask, Kunal, what if I don't want to take the outside value as the main value? What if I just want to do it like this? Like this. How can we do this? This is a very important point. Now you need this base condition. Now you're not like skipping one by one. So you actually need some value in order to like, okay, how many times you want to skip it, not skip, like how many times you want to shift it towards the left. So you can either add like int base over here, something like this. Okay, or you can add static int base times over, like times you will multiply it by 10. That is basically what I'm saying. You can add it over here, or what you can do is you can return the value of some other function. Okay, so you can say helper function. This takes n and it takes a base. Base can be anything. Let's first try to do it in whiteboard and then I'll teach you. So sometimes that happens, you might need, so basically the idea is sometimes you might need some additional variables in the argument. In that case, make another function, helper function. Okay, so let's see how we can do it. Okay, so what is the idea? Let's say the way number 2 is what? You're given a number, let's say for simplicity, you're given 1 2 3 4. Okay, 1 2 4 3, or no, for simplicity I can say 1 2 3 4. You have to reverse it. And what you can do is, maybe you can take another function. Maybe what we are going to do is, similarly we're taking the remainder 4 and we're adding 123 to it. But in order to add 123, this should be 4000. Okay, this should be somewhat like 4 into 1000 plus 123. We need this. That is what we need. So from where can we get this thing? That's a good question. It's actually equal to 4 into 10 raised to power 3 plus 123. Okay, and what is this going to be? The reverse of this. 3 into 10 raised to power 2 plus reverse 12. Okay, what is this going to be? 2 into 10 raised to power 1 plus reverse of 1. That is what it's going to be. So this particular thing I can actually pass as an argument. Okay, so I can just pass, initially the argument I can pass is what? The total number of digits minus 1. Total number of digits minus 1. So I can pass the argument like this. I can say f of n, and initially I'm passing the number of arguments. Number of arguments number of arguments I can pass in this, okay, it's going to be equal to what? The last, which is n, like the remainder multiplied by 10 raised to the power argument minus 1. My handwriting is not very good right now. Okay, never mind. I'll try to write it in a clear way. So right now I'm passing two things in the function call, because you understand why I'm taking arguments over here, right? You can also take it outside it, but right now I need it. That's why I'm taking it inside the call, and I'm going to create separate helper function for it. N argument is actually going to be equal to remainder multiplied by 10 raised to the power argument minus 1 plus reverse. What do I want to reverse? N divided by 10, and argument will now be reduced to, if it was 3 then 2, so argument minus 1. That's it. That is it. As simple as that. Okay, so I hope you're able to understand. I also formed the tree and all the pseudocode and everything. That is it. You know, once you try to analyze the patterns and everything, you'll be able to do it. Okay, so let's try to do it. I'm going to create a helper function. So I'm going to say return. So first of all, digits. What are the number of digits going to be? Integer value of math.log 10 of n plus 1. Okay, we covered this in mathematics. If you are not aware, hey Kunal, from where did you get this formula? Already covered in the mathematics video. Okay, so this is the total number of digits, and then I can just say return reverse. Sorry, no, I can make a helper function. I can make a helper function, and it will basically pass n and number of digits. That is it. Let's create it. It's gonna return actually. It's gonna actually return the reverse of a number. Hence, we will have integer. Obviously, now everything changes, because here you may have a question like, Kunal. Yeah, you may not have a question, because we are changing the original outside the value. So nothing inside this is getting changed, like only the outside variable are getting changed, hence no need to return. But here you do need to return, because actually things inside this function are being changed. Any variable, anything made in this function will be changed, because you know, right, if I make some variable over any variable we make over here, that will be only for this function call, and it will not be available outside it. Okay, if you want to access this digits in this other function, you cannot do it. Scoping, we covered this in functions. So no need to think about now, because we already discussed it. So I'm just going to say that first of all, if the number is a 1-digit number, return the number itself. Okay, otherwise what do we need to do? Otherwise we need to say return remainder. So return remainder into math.power of 10 digits minus 1 plus the function call, recursion call, n divided by 10 digits minus 1. All right, let's try it. Yeah, should convert it into integer. You should use long or something, because for bigger digits. So let's see, I'm gonna say reverse 2. Is this reverse 2? Yeah. Okay, and now I don't want to print the sum. I actually want to print this answer, whatever answer I'm getting from here. Can debug it if you want. Let me now run this. Should give me 4321. 4321. All right, hope you're able to understand how I was able to solve this using a helper function. Sometimes you may require such helper functions. Okay, cool. Let's move forward. Now another thing you can do is you can basically check whether a number is a palindrome or not. So I can use the similar concept. Okay, and by the way, we have done the palindrome function using like the while loop. You can try to convert that into recursion. Very simple, just like I did for this one. It's literally the same thing. Okay, let's try to do that. Just gonna rename this to reverse. And now for palindrome, it's going to be like static boolean palindrome number. Okay, so I'm going to say if number n is equal to the reverse of that number, then I'm going to say, or I can just say return this thing. Because this is a statement. This statement will either be true or false, right? So this statement will either be true or false, and I can just return it like this. So I can say is it palindromic or not? This is going to say it is palindromic. Okay, true. But if I remove like something from here and run this, then it's going to say false. Very simple stuff. Makes sense? If I took 1-digit number, it's going to say true. Easy peasy. Okay, now similarly you may ask, Kunal, what if we don't want to use this reverse function and use it on your own? You can do it. We have already done the palindromic function. Just check the first element with last element. Okay, this element second last with third last element, so on and so forth, like first and last, like that you can check. Okay, now we're taking indices. You can take that like a helper function. Okay, you can take a helper function. Let's try to do it. Let's do it. Yeah. Okay, so what if I want to figure out whether a number is a palindrome or not? Palindrome or not. So example number is given to you 1 2 3 2 1. How do you figure out whether it's a palindrome or not? We're going to say 1 2 3 2 1 is given. Check this and this, start and end we can take. Okay, so you can say start and end. This should be equal. Yeah, that's correct. Move forward. This should be equal. Correct. This should be equal, while start is less than end. Okay, we have done this. But over here, like, you do know, how can we solve this with like recursion? How can we solve this with recursion? So if my start and end are over here initially, in the recursion call, I can have start and end. That's correct. So I can add function call, the number itself, start and end. Something like this. Okay. Okay, but this is like checking whether a number is palindrome or not. And I think the first and last check that we can do, if you convert this integer number into, let's say, a string, then you can check that. Or if you have an array, then you can check like this is palindrome or not. But like for, I think checking a number is palindrome or not, I think this should be fine. All right, cool. That looks good. Let's move on to the next question. Another very simple question. You're given a number. You have to count how many, let's say, zeros are in that number. Okay, let me bring my whiteboard up. So let's say count zeros. Question: count number of zeros in a number. Okay, let's say number is given to you 3021409 or something. Let me take a smaller number, no problem. You're given something like 30204. Then the answer should be equal to 2. I don't think I should even do this. Just take remainder, check whether the remainder is 0 or not. That's it. That's it. While entire n is not equal to 0. This is very simple stuff. What is in this question? Nothing. Okay, but the thing is that you have to count the number of zeros, right? So how can we do this like in recursion? We have to return the count. You can either take the count inside the argument itself. Okay, so if we take count inside argument, let's do that first. If we take count inside argument, what will happen? It's going to be like function of n is going to be equal to, this is basically going to call any one of these two things. So notice what will happen if you're taking count inside it. So initially, let's say the count is 0. Two things will happen. If digit is equal to 0, then it will call what? Function of n count plus 1. Sorry, n divided by 10 count plus 1. Else it will call function of n divided by 10 and count. Hope that makes sense. Okay, here it's going to say count. Initially, let's say 3 0 2 0 4 is available over here. Count is 0. It's going to check for the remainder. Hey, is 4 equal to 0? No, it's not. Okay, count will remain that same. Number will now be 3 0 2 0. That's going to be like, hey, is remainder equal to 0? Yeah, it's equal to 0. Increase the count by 1. Okay, count will be 1. Number will be 302. Is remainder equal to 0? No, it's not. Count will remain as it is. Number will be reduced to 30. Is remainder equal to 0? Yes, it is. Count will be increased by 1. Number will remain 3. Is remainder equal to 0? No, it's not. Count will be remain. When it's equal to 0, then whatever answer you have, return answer. So basically, imagine what will happen. It will return 2. So this will return 2 means this entire value will be 2. This will also then return 2. This will return 2. This will return 2. And this will return 2. Oh, good. This is actually a good question in order to understand the flow of program for when you have to count numbers. Are you able to see how that when the number is reached 0, whatever count value will be over here, that is your answer. Can you see that? And I'm just returning it over here. When I'm returning it from here, where it will be returned? From where it was called from here. 2 will be returned. Since this answer is returned, this function is over. Here the answer is 2 because 2 was returned from the below. This will also then return 2. This will then return 2. This will then return 2. Then we return 2. Okay, so it's going to be like, hey, what is the answer you are getting? What is the answer you are getting? What is the answer you are getting? So it's actually returning the answer, whatever it's getting from the below. At every point of step, we are not doing return the argument. No, we are only doing return argument in the base condition. That is the main point. So whatever argument value of count is there in the base condition, that will be returned only once, because base condition will be hit once only. And whatever value is returned from there, that will be returned from everywhere. Important concept for count. I can write it important concept right over here. Okay. Try to debug it on your own, but it's very simple. I believe I explained it very clearly. So let's try to code this thing. Okay. Let's try to code this thing. So where is my editor now? All right. So I can say count zeros. This is actually a good question. Public and not just 0, you can count any number, but we'll be counting 0, let's say. I have to return the count integer int count in the number n, and I'm going to say helper n, and initially sum is 0. Okay. This is my count C. That looks good. And basically I'm just going to say that if n is equal to 0, return whatever count you have. This is a very simple question. Just make a tree on your own, write it on a pen and paper like I did, and we'll also try to debug it so that you are able to see how these things are flowing. See, if you follow what I told you in the first lecture, if you follow how the value is being returned, from there the function is exiting, from where the function is inputting, how the stack is filling up, how the stack is filling out, then you will understand any question. Same with this. And what is this? It's saying that remainder, it's going to be equal to this. If the remainder is equal to 0, count will increase. So I'm just going to say return whatever answer you are getting from n divided by 10 and count plus 1. Otherwise, you can say return whatever answer you're getting from n divided by 10, count will remain as it is. That's it. Let's try to run this. I'm going to say count number of zeros in 30210 or something. This should give me 2. Okay. If I add some number here, that should also give me 2 only. Okay. If I add 2 more zeros, it should give me what? 4 now. Pretty good stuff. As simple as it gets. We can also debug it. You can see if you want to debug it. So if you want to debug it, it's very simple actually. So here I can say just I'm going to move forward. So initially it's a very big number. It's going to be like, hey, what is the remainder? It's going to be like, it's 4. Okay, then just call, 302100 and count will remain 0 only. It's going to be like, yeah, okay. It's going to be like, now count will increase 1. So instead of calling this, it will now call this where count is increased by 1. In the end, you will see it will just have all the value of counts over here. C will now be equal to 4 and now n is equal to 0. So it will return 4. It will return 4 from where? From where this function was called. Either this or this. So either this entire value will be 4 or this entire value will be 4. And this will actually, whenever 4 is returned over here, it will return the function itself. So wherever this is being called, that entire value will be returned as well. So basically, if this was called in, if this entire thing was called in 30210, so this 0, let's say this is the part of 302100, then when you return this for 302100, then you can see that it's returning the value 4 only. So as you can see, this C is only being returned once. As you can see in our this also helper function also, now it's getting outside, but yeah, you can see this line was only hit once. Only 4 was returned once. Then it's just passing the 4 above in the above calls. That is what is happening. Special pattern. How to pass is a pattern. How to pass a number to above calls. How to pass a value, not just a number. How to pass a value to above calls. 4 is returned. You can see 4 will be returned to every single value. So as we see in the diagram as well, let me bring up my whiteboard. So it's going to be waiting for this. It will be waiting for this. So I can just write it over here. Special example to return value to return same value to above function calls. Okay, it's going to wait for this, it's going to wait for this, it's going to wait for this, it's going to wait for this. This is going to be like, okay, I have the final answer. It will return 2 to this. It's going to be like, okay, answer is 2. It will return to this. Answer is 2, return to this. Answer is 2, answer is 2. That's it. You can also use without this, like the, taking the outside variable. You can do that as well. It's very simple. Just take an outside variable like we did with the previous example. And yeah, that's it. Let's move on to the next question. Okay, so that was an interesting pattern to count the number of things. Okay, similarly in this step also, you have to count the number of steps to reduce a number to 0. This is a very simple question. It says that you're given a number, number, and you have to find the number of steps to reduce it to 0. What steps we can take? We can take 2 steps. If the number is even, divide by 2. Otherwise, subtract 1 from it. No problem. No problem. I can do it very simply. I can make a helper function. I can, yeah, let's do that. Okay, so I can say steps, public static void main. This will go over here, and I can just say return helper. You should not have this doubt like, Kunal, why are you taking helper? Whenever you want to, because your doubt about which variables to include in the argument of the function in recursion, that is already cleared. Hence, you should not be having, because I already covered it in the first lecture of the recursion, introduction to recursion. That is why we're taking a helper function. Okay, because we need to pass these values in recursion calls, and I can only pass values in recursion calls when I'm putting it in the argument. That's why I'm using helper function. Initial number of steps 0, for example. Okay, create a new method helper, total number of, let's say, steps. Okay, what is the answer for this? So if the number is 0, return the total number of steps. That's it. And dividing the number by 2 is one step. Subtracting 1 from it is another step. So basically, if the number is even, so if the number is even, in that case, well, this is one step, but here I'm just saying divide the number by 2. So num divide by 2 steps plus 1. Otherwise num minus 1, because if it's odd, and steps plus 1, because this is also one single step, like subtract the number by 1, divide by number by 2 is also one step. That is it. Copy paste, this should work. Okay, let me submit this. Let's run the code. That's it. Submit. How easy was that? Even though the question was easy, is important because this is also doing the same thing. If you want to look at it in the whiteboard, we can do that as well. No problem. Okay. So for example, the number is given to you, let's say something like 41. Okay. 41 is given to you. So you have to find the total number of steps. Let's say initially it's 0. So 41 is what? Odd number. Okay. If it is odd number, then it's going to be like, okay, increase the number of steps by 1 and reduce this number by 1, because that's what the question says. Number will now be 40. Function call. Number is even. Okay, increase the call by 1, reduce the number by half. That's it. Okay. Increase the number by 1, reduce it by half because it's even. Okay. Again, it's even. Reduce it by half. No problem. This will keep on increasing by 1. This will now be 5. It's odd, so it will be like 4. No problem. Okay. Now this will be divide by 2, 2, 6. And then it will be 1, because divide by 2, 1, 7. This will be 1 minus 1, 0, 8. Total 8 steps. For 41, total 8 steps are required. How simple is this, right? Why did I not, like, I did explain it in detail, like, you can see I debugged it like on pen and paper, and it's pretty straightforward. Like, what else do you want me to say in this? It's literally like the same approach we did previously, right? So you can see, like, if I try to put a test case of what 41 over here, and I try to run this, let's see what the answer will be. It should give me 8. I'm getting 8. All right. So this was the recursion easy questions video. Hard questions, all the ones that I mentioned previously, will come. If you want to show the support to the channel, make sure like, share and subscribe. Like right now and comment right now. I would highly appreciate it, because if you comment, then other people will be able to see this. So it wasn't much about, let's say, the easy problem, but more about the patterns. Because if you're new to recursion, so please make sure you check out the assignment link in the description. You can also check out various platforms where you can find recursion problems like HackerRank and LeetCode and stuff. All the links are in the description. Notes you can find in the description. Code samples you can find in the description. And I'll see you in the next one.